2020 Exam 2, Question 4, Data Analysis. Looks like we actually have to get the calculator out. I put all this data into list 1, list 2, and list 3. The first one is the median age in years. That's not hard to work out. There are 12 data points, they always tell you, and you can easily see, like, look halfway. Looks like there's 24 either side, so it's 24. And then it wants the mean of body density. That's my list 2. So I went to the calculator and said calc one variable, and there's my x bar, which is the mean, 1.065, 1.065. Didn't ask you to round, so don't round. I know. Okay, now we've got this data, and they're saying they want to do a least squares line with the aim of predicting body density from weight. So which one's the explanatory variable of those two? Apparently people choose other variables. 50-50, not really. The prediction is the y-axis and the explanatory is the x-axis. So it is weight is on the x-axis. So remember, the prediction is the one that's varying, okay? And that's the y-axis. So next one says determine the slope of the least squares line, otherwise known as the gradient. And you should have your calculator set to y equals a plus bx. So we're looking for the b value, and it does say round the answer to 3 significant figures. This could be a little bit tricky. So grabbing my data, and I had to be careful because I remember my x list, which is the weight, is actually list 3, and my y list is list 2. So very important that you're getting that part right. And then I come up with my b value, and it's in here, and they know to do this to annoy people. So we got minus 1.116, and then you get that e neg 3. So you can't write that, you'll be in trouble. So you've got to translate that. So this e means exponent. So this is exactly the same as saying minus 1.116 times 10 to the neg 3. And I think they should allow that because it's just scientific notation. They didn't say anything in the answers about that. But the problem with that is also that we've got 4 significant figures. So let's look at the significant figures. That's significant, that's 3 already, so we've got to round that off. So it is minus 1.12 times 10 to the neg 3. Or, if you know, when you've got a negative number, you're moving the decimal place to make it smaller 3 times. So you're going to move that decimal place 3 times to here. So you get minus 0.00112. Didn't say whether scientific notation was allowed, but do not do this, and don't forget your significant figures, and you should be all right. Okay, so don't ignore that e neg 3. I know some people actually just do that. They're just going to go, oh, I don't know. Also, if you did this on your calculator, you probably didn't get that graph down the bottom because your graph might have been graphing list 1 versus list 2, not list 3 versus list 2. This one looks normal. If you didn't get that graph at the bottom with a nice line, that negative gradient, which you said negative gradient, don't forget the negative symbol, then it's probably because you just add the long lists set for your set graph. And then after you pressed OK, something goes, oh, hang on a minute, you need to find what percentage of the variation can be explained by variation in weight. That's code for what is r squared. Remember, r squared is always percentage, and it does say round your answer to the nearest percentage. So our r squared value is here, and so you've got to times that by 100. So it is 0.2899537 times 100. You should be able to see that you're just going to move it 1, 2 decimal places, round it off, 29%. Please don't be the person who can't round.